Okay, so number 4 is an interesting problem. Not interesting. You will, I'm like 99.9% certain that you will have something like this on your midterm. You will be given a problem, you will be given a schematic of a real bridge and asked to draw the tension and compression members, the main ones. So in this particular case, for this problem, I recommend that you just print out print out this page and attach this page. So draw, instead of redrawing the entire diagram, just label your tension and compression on the diagram itself, and turn this sheet in for problem 4. You don't have to copy it out by hand. Just print this sheet out and do all your work on this sheet. When he's asking to draw the tension and compression members, you only have to draw the obvious ones. So, for example, if you see an arch, yeah, like this would be, in my mind, the arch would be the obvious one. This is going to be obviously compression, just because an arch is almost always in compression, in pure compression. So in this case, I would have an arch, something like this. And I recommend that you actually get different colored highlighters or different color markers or something, because that's the easiest way to do this instead of labeling everything T or C. So in this case, I would label this as C, because my highlighter is not that wide, but I would also just say up here that green equals compression. And let's say that red equals tension. So if you do this with different colored highlighters, it's if you do this with different colored highlighters, this is much easier to see. In this case, I would say that the pylons here, these are almost certainly in compression. And you can try and guess which ones in here are in tension. I would actually say that in this case, the deck is probably in tension, just because this is a type of bridge that we call a cantilever bridge. So I'll let you guys guess, or not guess, but try to come up with your best responses as for why what the dotted members indicate. I know we had some interesting discussions about this in office hours, so I'll leave that up for you guys to analyze. For B, do the same thing. Just label which ones are tension and compression. Note that you have opposite curvature here. This is concave up here, and then right here it switches to concave down, and then concave up again. So I'll just provide a little bit of background on this. This is an older bridge. The first one is an older bridge. Part A is like a prototype for part B. We learned a lot when we were designing bridges like this. We stopped designing bridges like this and we designed them more like this one for a while. So the two questions that he asks here, or the question that he asks here, what could the dotted members indicate? That's kind of leading you into part B, and I'll just leave it at that. It's asking you to think a little bit outside the box, to use a little bit of your, just to see if you guys have an intuition for this yet. Don't worry if you're having difficulty with it. Don't spend too much time on this. Just try and think about it and try and come up with a reason that seems logical, and then we'll go over the solution in more depth later. For problem B, or problem C, note that we have, this is like a type of suspension bridge. So you're going to have members that are obviously in tension. In this case, the cable up here, this is known as a catenary. This is a type of curve that you get when you hang a wire or a cable or a chain between two posts. So it's not a parabola, it's not a sinusoid, it's not a circle. There's a special type of hyperbolic sign. This is a very special kind of curve. It's very special in certain cases of stability. for special architectural purposes. So, for example, the St. Louis Arch is actually not an arch; it's a catenary. It's an inverted squash catenary. I think that's the actual terminology that's used to describe it. This is going a little bit more in depth than you really need, but whenever you have a catenary, is basically an upside down arch, and whenever you have a catenary, you have tension. Whenever you have an arch, you have compression. Those are the two main rules to follow. Those are the two main things you'll be drawing on your diagrams. Don't worry too much about don't worry about the internal members here. So basically just focus mostly on the ones that are on the outside. And things like this one in the middle here, this is obviously in compression. Or I think obviously in compression. This one is obviously in compression. These I think are in tension, because this is a type of suspension bridge, so you're hanging off of cables here. And I think I gave you guys enough hints for this one, so I'll let you guys solve the rest. But let us know if you have any other questions. I think he's going to spend some time on this on Friday to give you a little bit more background. So this is kind of like what's your initial impressions of this, and he just wants you to start thinking about this so that he can have an interesting discussion with you guys on Friday. But yeah, other than that, please let us know if you have any other questions.